Now, we want to look at quadratic functions, graphing quadratic functions by transformations. And what you need to remember is how do we determine this is a quadratic function or not? A function has the second degree as an exponent is the highest, right? And we saw the general quadratic functions. Now we am giving you a name, okay? The general quadratic function is basically f of x is equal to ax squared plus bx plus c. If it is in general function, quadratic function format, we cannot do transformations. So therefore, the quadratic function must be rewritten in terms of, some texts will call it standard form or vertex form. We need to rewrite it into this standard form or vertex form, which is here. F of x is equal to a times x minus h quantity square plus k, where h and k, remember, those are your vertex. Okay? So what we want to do is we want to use the transformations to graph this. So first of all, for example 1, that is in sort of transformation format already. You can see that my parents' graph is y equal to x squared, right? My parents' graph is y equal to x squared. And we want to transform that. Notice that this x squared is representing your y value, and we are subtracting 5 to y value, which is y equal to x squared minus 5. So we are subtracting y value by 5. That tells me it will be shift down, right? Shift down. That tells me it will be shift down 5 units of your original parent's graph. So let's quickly draw a parent's graph, and then we're going to do the transformations. Okay, so if x is 0, so meaning I'm going to be plugging into my parent's graph. When x is 0, 0 squared is 0, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, negative 2 squared is also 4. So that is my parabola of the parent's graph. Now we're going to do the transformations point by point. So we are shifting down the entire graph by 5 units. So first point, this point, if you shift down 5 units, that will become right here. Okay, that will become right there. Then the next point, if I shift down this point 5 units, it will be 1, 2, 3, 4, 5, which is right there. Next, if I shift down the next point, this point 5 unit, that will be 1, 2, 3, 4, 5, which is right here. And I can use a symmetrical idea to do the transformation graph, or I can continue what, shift it down one by one, right? So I erase one of the point. So if I shift down this point 5 units, so it'll be 1, 2, 3, 4, 5. And if I shift down the next point from the parent's graph, so you don't have to shift every single point. If you see the sketch already, then you can basically, like, graph sketch it. So now my final graph will be what? A parabola shift down 5 unit from the parent's graph. Let's take a look at the next example. The next example, I am subtracting 4 to my x value, my input. So therefore, this tells me the graph gonna be shift to the right 4 units. So my parent's graph will be y equal to x squared. And this time y equal to, now I'm subtracting to my what? X value by 4. So this will be telling me it will be shift right this many units, 4 units. So shift right 4 units. This is shift down 5 units. So now, graphing the parent's graph quickly. Now I'm only going to use 3 point because we graph a few times already. So 0, 0, 1, 1, and then negative 1, 1. And if you want a better graph, it will be 5 point is better, right? So now I have my parent's graph right here. And we're going to shift to the right 4 units for this time. So this point shift to the right 4 unit will become right here. This point, if I shift 4 unit to the right to 4, which is going to be right here. I shifted wrong. It should have been the point right here, 4 unit to the right, and then 4 unit to the right for the second one will be right here. And if I shift this point 4 unit to the right, it will be 2, 4 right here. Now shifting the other side, if I shift this point 4 unit to the right, it will be 1, 2, 3, 4, which is right here. And now you can see that we have the graph already, so we can basically what? Sketch it. I have some technical difficulties right here because the pen is not exactly where I want them to graph. It's moving differently. Okay, here we go. And then that will be my final graph after shifted to the right 4 units. So moving on to the next one. And you can see that this time I'm adding x squared by 7. So the whole entire graph is going to be shift up 7 unit. So my parent's graph is basically y equal to x squared. And then x squared plus 7. So you notice that this y value got added by 7, so it'll be shift up 7 units. So my parent's graph, when I plug it in a few points to my parent's graph, 0 will be 0, 1 will be 1, negative 1 will be negative 1, or positive 1, 2 will be 4, negative 2 will be also 4. So now we're going to shift this parabola upward 7 units. So transforming, when I shift this point up 7 units, which will become right here. When I shift this point up 7 unit, which will become right here. And if I shift this point up 7 units, that will become at 11. And then on the other side, it will be symmetrical, so I can basically use the symmetrical idea to graph it or continue shifting the point. And this will become the graph. And notice that on the next example, I'm adding my x value by 6. So that tells me my parent's graph if y equal to x squared. And I'm adding to x value by 6, which will become, it will shift left 6 unit. Right? Shift left 6 unit. So my parent's graph, the point is right here, 0, 0, 1, 1, negative 1, 1. And 2 will be 4. And negative 2 will be also 4. And how do I get these points? plug it into my parents graph. X value, and then that will give me my Y values. So I got my parents graph. And now we're going to shift this to the left 6th unit. So shifting this point to the left 6th unit will be right here. Shifting this point to the left 6th unit will become right here. And then shifting this point to the left 6th unit, that will become right here. And then using the symmetrical or do the transformation like before, then this will help me to get the rest of the point to help me to graph this parabola shifted to the left 6th unit from the original graph. So now we want to do a little bit more extra, right? So from this is a vertex form or standard form. So I know that from this square, our graph will be a parabola. So the parent's graph will be y equal to x squared. That's how I quickly note, distinguish, right, or classify what is my parent's graph formula is going to look like. And then I start working on one by one. The order that I told you earlier, which is do the reflecting first, and then stretching, and finally shifting left, right, up, down. So in this case, no reflection. So I'm gonna start with x plus 2 to the 2nd power. So we are adding 2 to my x value. That means it will be shifting left and right. Because of I'm adding, it will be shift left 2 units. And then finally, x plus 2 square minus 3, you are subtracting to this square part, which is my y part, right? See that? This, my y is what? X squared. So this is basically talking about, since you are subtracting, it will be shift down 3 units. So first we're going to graph the parents graph and then plug it into here. I got these points 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, also 4. So I got my parents graph. And we're going to do the shifting from this parent graph. So shifting, when I shift this point, it will shift to the left 2 units and then shift down 3 units. So shift to the left 2 unit will be right here, and then shift down 3 units. So let me show the arrows to you. Okay. So I'm shifting this point right here. Shift to the left 2 units will be right here, and then shift down 3 units will be ending up right there. So that's my point. And then I'm going to shift the next point from the parents graph, this point. So if you shift to the left 2 units, and this will be right here, and then shift down 3 units, it will end up right there. For the next point, this point, if I shift to the left 2 units, this will be right here, and shift down 3 units, which will be ending up right here. So using the symmetrical idea, you can sort of like look for the points, right? Look for the points, or let me graph this again. Look for the points, or you can, like, use a symmetrical idea to plot, get the points. So here's another point symmetrically, and here's another point symmetrically. So we can use them to graph it to make it needed. So the entire graph shift to the left 2 unit and then shift down 3 units. Now, moving on to the next one. This time we're gonna be reflecting and also stretching, because look, my parents' graph is y equal to x to the second power. Now what we are looking at is we are reflecting, which is negative, and also stretching by, because what, multiplying by 3. Okay, so let me go one by one so that you can see this better. And here you go. This will be reflect about x-axis. That will be just minus part. And then when I multiply by 3, that will be also what, stretch. Okay, stretch vertically by factor of 3, meaning so every point will be multiple of 3, multiplied by 3. So my parents' graph right here will be 0, 0, 1, 1, and then 2, 4. Negative 1, 1, negative 2 will be 4. So these are my points for the parents' graph. Now I'm going to do the transformations. Okay. So let's take a look at on this point. 0, 0. And remember, when I'm reflecting and then stretching, we are multiplying to our y value, okay, by negative 3. So the first question is, my first point, my y value is 0. If I multiply by negative 3, so negative 3 times 0 will be still 0. So this point, when you reflect and shift, stretch, it will be still right here. It doesn't move. The next point right here, this point is 1, 1. And we know that we are reflecting and then stretching because I'm multiplying to my y value by negative 3. So this is basically what it will be. If you reflect it, it will be going down right here. And if you stretch by a factor of 3, if you multiply by 3, 1 times negative 3 will be 1 times 3 will become 3. So it will become negative 3 right here. So you stretch it out. So another way of saying is you're multiplying your y value by negative 3. So my new point become, when I multiply by negative 3, it will become 1 times negative 1, negative 3 is my new point. Moving on to the next one. So reflecting this point right here, remember this is 2, 4. If I reflect about the x-axis, 2, 4 become 2, negative 4. Right? 2, negative 4. But however, you are stretching by a factor of 3, so you're going to multiply negative 4 by 3, it will become negative 12. So you stretch it out by a factor of 3, so it will become all the way down here, negative 12. So another way of saying is we are multiplying my y value by negative 3. So that's what become my new point become 2, negative 12, which is way down there. That's the transformation of this point. Similarly, on the other side, if I transform this point, that will be negative 1, 1. If I reflect about the x-axis, which will be go down here, but however, you are stretch it vertically by a factor of 3. So negative 1, when you multiply by 3, a factor of 3, negative 1 multiplied by 3 become negative 3. So another way of saying is this y value got multiplied by negative 3. So we got my new point become negative 1, negative 3, which is right there. So now you see that how it's stretching and then reflecting at the same times. So with this point, we can basically graph it along neither, because of its stretching. Of course, my parabola will be around narrower, and then on this side will be going down deep like this. And this will be my transformations for this graph. Next one is transforming again, but it will be horizontally shrinking because I'm multiplying by less than 1 half, right? So again, my parent's graph will be y squared, and then we're gonna be y equal to x squared, and then we're gonna multiply by 1 half to that y value, so it will be what? Vertically shrinking by factor of half. So my graph will be right here at 0, 0, 1, 1, and then negative 1, 1, and then 2 will be 4, negative 2 will be 4, and these are my graph, right? My points on the graph, parent's graph. Now let's do the transformation. This point, 0, 0. And we are multiplying 1 half to my x squared, which is my y value. So I'm multiplying this y value by 1 half. 0 times 1 half is still 1 half, so it will be not changing for this point. Okay. Now, move on to the next point. This point. That is 1, 1. And you are vertically shrinking by a factor of half, meaning your y value got multiplied by 1 half. So we are multiplying this by 1 half, which my new point become 1 comma 1 times half will be half. So this point basically is shrink it down into a half right here. Next, for this point, that is 2 comma 4. And we are vertically shrinking by a factor of half, so my y value will be multiplied by 1 half power. So this multiplied by half. So my new points will be 2 times 4 times half will be 4. So this point becomes shrink it down to 2. So symmetrically, I can say that here's a point half, and here's another point right there. So notice that the graph is vertically shrink it down, so therefore it was what? Wider. And that is my final graph for this shrinking. Earlier, I mentioned it before that if your function is written in general format, we won't be able to use the transformation. So how do we change it back into a standard form or a vertex form? So remember, the standard form or vertex form is this f of x. Right? F of x is equal to a times x minus h squared plus k. So to write it into this format, the important thing is we need to find out what is our vertex. And we already learned how to find the vertex. So the x coordinate of the vertex, that is basically h, which is minus b over 2a. And we know that a and b's are coming from this quadratic functions, which is my b in this case is 12, my a in this case is negative 3. Therefore, my answer is 2. And my y coordinate is k. That's basically the function evaluating at the x coordinate of the vertex, which is in this case is 2. That is minus 3 times 2 to the second power plus 12 times 2 minus 4. That's give us negative 12 plus 24 minus 4, which is 8. So now I know my h and k, so I can plug it in. F of x equal to my a is the value right here, negative 3. X minus my h, that is 2. Quantity squared plus my k, in this case, is 8. So basically you plug it in back. And this helps us to sketch my transformations, which we're going to reflect. Okay? We're going to reflect and then stretch and then shift to the right 2 units and then shift up 8 units. So graphing the parents graph first to get the points. 0, 0, 1, 1, negative 1, 1, 2 will be 4. Negative 2 will be 4. That's my parents graph. And using these points, I'm going to do the transformations. So point by point. First point. Oh, I forgot to write this down. This is reflect x-axis and stretch by 3, by factor of 3. Okay. So for this point, 0, 0, when I reflect and stretch, basically I multiply by negative 3 to my y value, right? So 0 times negative 3, it will be still 0. And then I'm going to shift to the right 2 units and then shift up 8 units. So my graph, my points is right here. Now, moving on to the next point. This point right here. That is 1, 1. First, we reflect. Always reflect and stretch first. So that means I'm going to multiply my y coordinate by negative 3, right? Reflecting it. So that means if I reflected this point, it will become negative 1 because if I multiply by a factor of 3, 1 times 3 become negative 3. Here's a point. Now I'm going to shift to the right 2 units and then shift up 8 units. So 2, 4, 2, 4, 6, 8 here. So I got my new points already. Shifting the next point. This point right here. That is 2, 4. So when I reflect, so about the x-axis, this 4 reflect about the x-axis become negative 4. And if I multiply by 3 to that point, that become negative 12. So another way of saying is my y coordinate will be multiplied by negative 3, reflect and stretch it. So that means that will be 2, negative 12. So 2, negative 12 is way down here, right? And then I'm going to shift to the right 2 units and then shift up 8 units. So it will be 2, 4, 6, 8. It will become right here. So now we got the points. And after that, what we do is we can use the symmetrical idea to get the other ones, not the transformation. So you can see that on the right hand side is point right here. So on the left hand side, it must be a point right there. And the next point is 2 units to the right of the vertex. So it will be 2 units to the left of the vertex, and then it should be right here. So now I got my transformations, and using also symmetrical idea to graph this. And notice that it is upside down. We know that already, right? Because of the negative coefficient. And then the graph is a lot what? Narrower, because we are multiplying, we are stretching by a factor of 3. And the entire graph shift to the right 2 units and up 8 units. That's the transformation. Next, similarly, I want to graph this. Okay? So first I need to put it into vertex form, which is f of x is equal to ax minus h squared plus k format. So I want to know what is my h. That will be negative b divided by 2a, which is negative of negative 6, 2 times 3, which is going to be positive 1. And my k, my y coordinate, is basically f of 1. That is 3 times 1 squared minus 6 times 1 plus 5. That gives me 3 minus 6 plus 5, which is 2. So from here, we know that f of x equal to my value a, that is right here, 3, and then x minus my h is 1. Let me just plug it into the formula. Square plus my k in this case is 2. So this tells me from here, this tells me we're going to be stretched by a factor of 3 vertically, and then shift because of minus to the right 1 unit, and then shift what? Up 2 unit because of the plus sign. If this would have been minus, then it will be shift down. If this would have been plus, then it will be shift to the left. Okay. So now continuing this, graphing the parents graph, which is y equal to x squared. 0, 0, 1 squared is 1, 2 squared is 4. Negative 1 squared is 1, negative 2 squared is 4. So I got this graph. Now I'm going to start the transformations. First point right here is 0, 0. Since we are stretching by a factor of 3, I'm multiplying the y value by 3. So 0 times 3 is 0. So my point, this point, isn't changing anywhere. Now I'm going to shift it to the right 1 unit, which is right here, and then up 2 units, so end up right there. So that's my transformation for the first point. Now, moving on to the next point. This point right here, that'll be 1, 1. We are stretching by a factor of 3, so you are multiplying my y value by 3. So this will become 1, 3, the points. So this point, after we stretch it, it will be 1, 3 right here. And then we're going to move to the right, shift to the right 1 unit, and then shift up 2 units, so it will end up right here. So next, moving on to the point, this point right here, that is 2 full. And we are stretching by a factor of 3, so multiplying the y value by 3. So this will become 212. That will be way out of the graph right now. Okay, so 212, so 212 is way up here. Okay, and I'm gonna shift to the right 1 units and add 2 more units, so it's gonna be way up there. So we don't really need that. So I can use symmetric idea to get another point on the left of this, which is gonna be right here. Right? This is my center, so now I can graph this. That'll be the transformation. And this conclude the sections.